I might get a little bit lost, but I eventually get it. This is minimum cost 983 for tickets. Okay. So you have planned some train traveling 1 year in advance. Okay. The days of the year in which you would travel are given in an integer array days. Okay. Each day is an integer from 1 to 365. All right, so you're just given this array. It's like day 7, you're going to be traveling. Day 8, you'll be traveling. Day 24, you'll be traveling. Day 36, you'll be traveling. Whatever. That essentially just means what? It means that you're going to be taking a train that corresponding day. Now, you can buy a train ticket in 3 different ways. You can buy a 1-day pass, and that'll cost $0. Okay, so there's some associated costs with buying a 1-day pass. There's some associated costs of buying a 7-day pass. And there's some associated costs of buying a 30-day pass. Right, so if I'm going to be traveling 27 of the next 30 days, it might be more cost effective to just buy the 30-day pass, right? Even though I might not be traveling 3 of those next 30 days, it's probably more efficient to buy one 30-day pass that covers that range rather than buying 27 1-day passes, right? Because you probably get some sort of deal, I guess, right? There's probably a price cut if you buy a longer pass. So kind of an applicable problem to kind of situations that we see ourselves in. The passes allow that many days of consecutive travel. Yeah, it makes sense. If I buy a 30-day pass, I can travel for 30 days. So if I buy a 7-day pass on day 2, I can travel on day 2, 3, 4, 5, 6, 7, and 8, right? So 7 days. L, because I'm a loser. Okay. Return the minimum number of dollars you need to travel every day in the given list of days. Okay, so you have all these days that you're given that you want to travel. So I want to travel on day 1. I want to travel, I want to travel on day 1. I want to travel on day 4. I want to travel on day 6. I want to travel on day 7. I want to travel on day 8. And I want to travel on day 20. Okay. And the cost for each corresponding pass, well, a 1-day pass is how much? A 1-day pass is $2 or 2 whatever units of money that you use wherever you're from around the world. A 7-day pass is $7, and a 30-day pass is $11. Why did I say 11? I was reading the wrong thing. $15. All right, so these are the corresponding costs for a corresponding pass, right? So the 1-day pass is at this first index, right? Cost of 0 is the 1-day pass, so that'll be $2. Cost of 1 is the 7-day pass, $7. Cost of 30-day pass is $15 in this position, right? And you get a deal, right? If for a 30-day pass, it costs $15. But if I wanted to get 30 consecutive 1-day passes, it would cost me $30. Or 2 times 30, $60, right? Because I'd have to pay $2 each day for 30 days, $60. Simple arithmetic. Apparently, I can't do it. Okay. So the optimal solution here is 11. Why? Well, it just goes through here, For the first day, you can just buy a single 1-day pass to cover this. You can cover this 4-day period by getting a 7-day pass, and then buy another 1-day pass to cover day 20. So the solution here, I think, can easily be understood if you think about it as a graph, right? Because I guess the first observation, the only observation you really need for this problem is that, you're going to have to buy a pass that covers each day, right? So when you're dealing with a day, the first time you see that day, you're going to have to, if you encounter a day and you don't have a train pass, you're going to have to buy a train pass to cover that day, no matter what, because you have to cover all the days, right? So when I go on day 1, I'm going to have to buy a pass, right? So every time I encounter a day and I don't have a train pass, I'm going to have to purchase a train pass just so that I can use it for that corresponding day. Maybe it's better to buy a 1-day pass on day 1 or a 7-day pass or a 30-day pass, but regardless, if I don't have a train pass and I'm at a certain day where I need to travel, I'm going to have to buy one regardless, right? So you can model that as a graph saying, well, what I'm going to do is model every single day. Okay, so we have day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, day 9, day 10, day 11, day 12, day 13, day 14, day 15, day 16, day 17, day 18, day 19, day 20. Okay, then I'm going to color the days where I need to buy a pass, right? So I'm going to have to buy a pass on day 1 if I encounter day 1, day 4, day 6, day 7, day 8, and day 20. Now, when I encounter a day, so say I'm at this first node here. When I encounter this day, I have to buy a pass because I'm at this day, and I have options about the passes that I'm going to buy, right? And there's corresponding costs associated with those purchases, right? So at day 1, what are the things I can do? I can buy a 1-day pass that just brings me here, and that's going to cost $1. I can buy a 7-day pass so I can travel day 1, day 2, day 3, days, and get me all the way to day 8, and that's going to cost me $7. Or I can buy a 30-day pass, and that'll push me off the screen, right? Because it'll be after day 20, and that'll cost me $15, right? So if I was to decide to kind of take a 30-day pass here, right, and spend $15, then I'm done. I don't need to consider the rest of the days because I'm not going to encounter them again, right? If I buy a 7-day pass, then I don't need to consider days 4, day 6, or day 7 anymore because I'm going to be covered for those days. But when I encounter day 8, then I'm going to have to make that decision again because now it's day 8 and I've just used my 7-day pass. So now I need to make that decision again. So using this idea of an edge where the edge's weight is the cost of that ticket and the length of the edge, right? The number of days you get to jump is the number of day pass that the number of days you get, the number of days of which that day pass is valid, right? So essentially, if I use a 7-day pass for $7 at day 1, I don't need to think about 4, I don't need to think about 6, and I don't need to think about 7 because those days are covered, right? So basically, when I'm using an edge, it's telling me those are the number of days that I'm covered, right? And just to kind of articulate another point, when I encounter day 2, I don't need to pay any money because I don't need this day, right? Because this day isn't highlighted because this day isn't one that I'm traveling. So since I'm not traveling this day, I don't need to think about the fact that that day is not covered. I can just go right to the next node, right? So you could say that every single one of these black nodes has a cost 0 path going to the next node, right? Because that's just basically saying, okay, I don't need to spend anything. I don't need a day pass on day 2. I don't need a day pass on day 3. Now I'm at day 4 and I don't have a pass if I was to choose to use this dollar path. Right, so I'm at day 4 and I don't have a pass. So what am I going to do? Well, I could play this same exact game. Right, so for day 4, I could spend $1 and go to the next node. I could spend $7 and go 1, 2, 3, 4, 5, 6, 7. And go here. Or again, I could go a whole 30-day pass and I'd be off the board for $15. So I'm not going to continue to enumerate through this every single edge, but you can see that the basic solution for this problem is basically, well, you have a directed acyclic graph, right? And at any day, right, at any generic day, right, so we have this day node. If we have to travel that day, right, if we have to travel that day, the cost is going to be the minimum cost. Okay, well, I'm trying to think about how I'm going to articulate this so it's... Yeah, so I could solve it in reverse. So I could solve this problem in reverse, right? So I could solve for day 20, then day 19, then day 18, then day 17. Could I solve it in reverse? Yeah, it'd be the same problem. Or you could do it the other way. So it'd be the same thing the other way. So for this day, I could say, well, if I have to travel this day, right? So if this is a day that I have to travel, then I know I'm going to have to buy a pass that covers this day at some point. So to buy a pass that covers this day, I could either have bought a day pass that covers this day with price 1. Right? I could have either for any day, right? In order to cover that day, I'm going to have to buy a day pass that I could buy a day pass that covers that day for $1. I could buy a $7 pass to cover that day, or I could buy a $30 pass to cover that day. So then these corresponding nodes, this would be day -1, this would be day -7, and this would be day -30, right? And at each of these nodes, they would have their corresponding costs to travel up to that system of nodes, right? So I'm basically just using a recurrence relationship based on these systems, right? So if the node is highlighted, right? Because if the node is not highlighted, then I can just take the previous day's path. So the cost for any single day is, well, if it's highlighted, I would look at the previous day, the 7-day, and the 30-day, and just take the minimum of it, right? So let's say that generally D is the cost Man, I was doing so good in the beginning, and now I'm just losing my edge, it seems like. For some reason, my head is down here, and I don't know why. All right, so D of day is the minimum cost to travel all days less than or equal to day. So basically it's saying D of day is basically saying at this day, what is the minimum cost such that I travel all the days that come previous to this day, including this day, right? So D of 6 would be the minimum cost to travel up to 6 using 1, 4, and 6, right? Covering all of these previous days. Okay? So that means that D of day, if I have to travel, so if I have to travel on D-Day, it's a bad video, I apologize, guys. If I have to travel on D-Day, well then it's just the minimum of, well, what are the edges going into each node? Well, I can either go to the previous day, so whatever the minimum cost is to the previous day, but I have to use this day pass, right? I could do a 7-day pass, but then I have to spend whatever the cost is for that. So maybe to make this, let's make this more generic. So this would be cost 0. We could do the day -7 for a 7-day pass, and that would be the cost of the 7-day pass. Or we could do D of day of the 30-day pass, and that would cost the 30-day pass. All right? Does that make sense? The idea is, if I have to travel on a certain day, then I'm just going to look at the day. Since I have to travel on it, I'm going to have to buy a ticket that covers this day. So either it's going to be the cost of a day ticket to cover this day, or the cost of a 7-day ticket to cover this day, or the cost of a 30-day ticket to cover this day. But that's only if I have to travel that day. If I don't have to travel that day, right? If I don't have to travel that day, then it's this situation here, right? Here I don't have to buy a ticket at 14. I can just grab the previous price from 13 and take that into account. Whatever whatever it cost me the previous day would be the same today because I don't have to buy any additional day pass. So otherwise, D of day equals D a day minus 1. Okay, so this is essentially the formula in the system. Now, the issue is that this system is given as the days that you want to travel, not all the days that exist, right? Right. I wrote this system out as all of the days in the range from the first day you want to travel to the last day you want to travel, but that's not necessarily how the system looks here, right? Because, well, maybe I could do it. No, that won't work. Okay, so, sorry, I was thinking. So this wasn't given as just an array where each of the days is highlighted or something, right? This was instead given as the days where each of the days you want to travel are noted. So you might say that it's space inefficient or time inefficient if we take the days and we convert it to this array here where there's highlighted notes. So what you could do is take this system and create a corresponding array where what? Where each of the okay. So we could create an array where each of the days that's highlighted, right? So day 1 would be 1. We don't travel day 2. We don't travel day 3. We travel day 4. We don't travel day 5. We travel day 6. We travel day 7. We travel day 8. We don't. We do. So essentially you just make this bit array that is the size of the min day and the max day to keep track of the days that you travel and the days that you don't travel. And if this is a 1, that means you have to travel that day. So you would compute this recurrence relationship here, and if the day's a 0, then you just take the previous cost from the previous day. Now, this isn't space or time inefficient because there's only at most 365 days, right? So this thing can only scale with 365 days. It can never be larger than that, so it's never going to be larger than what n is itself, right? And we can make this O of n, where n is the max day, right? And it still be proportional to that, because the worst n could be is that you travel every single day in the range. So this is essentially proportional with n, which is the number of days. So even though we're taking this array, which is only size 1, 2, 3, 4, 5, 6, and we're making it size 20, that's fine, because it can only go at most 365 in terms of its size. And this is far easier to do the recurrence relationship instead of trying to think about, like, okay, if it's the previous day, but the previous day isn't one of the days I'm traveling, what should the value be? Things like that. It's just far more inefficient that way. So this is just going to make it a little easier to process. So let's go ahead and get right into it. I'm rambling too much today and not writing enough solutions. Okay, so let's create this D array. It's going to be 0 for everything. And then we'll make it, the length of it, the maximum number of days that we're going to travel, plus 1, because we start with day 1, but it's index 0. And then we'll look at each day in days, and we'll set D at that day to 1. Okay? And now we just do the recurrence. So now I'm basically setting this bitwise array, right? I'm setting each of the days to 1, and otherwise it'll be 0. And then we just need to look at each day in the range. So each day in range length of D. So we look at each day, and then we say, okay, well, the D of this day, if this day is some day we have to travel, so its bit is set to 1, well then, or we could do it this way. So we could say D of day equals the min of D of this day minus the pass. So we'll call it X pass for the length of the pass. So it's an X day pass. So if we get an X day pass, we consider the price from that X previous days plus the cost of X. And what are our options? Well, we can do X pass, X cost in, so there's 3 pairs. We could spend a 1 day pass, and that'd be cost of 0. We could do a 7 day pass, and that'd be the cost of 1. Or we could do a 30 day pass, and that'd be the cost of 2. So that would be my corresponding costs if the day exists. Otherwise, our cost would just be d of day minus 1. Oh, d of the previous day, whatever the cost is to the previous day. And then we don't need to do the 0th day. Except, okay, so this could scale over, right? Because if you're on day 2, I don't know why I did link there. I don't need to link. It's just the day that you're on. Cost is not defined because it's costs. All right, so then at the end, your total cost is just the price to get to the very last day, right? Because every day it'll tell you the price it'll cost to cover all the days up to that day, so up to the last day. All right, cool. So what's the runtime and what's the space? Well, the thing about this is we could just say, well, we have 365 days, right? So at most, at 365 days, right? So this system is big O of 300, at most 365 operations in terms of time. And then same for space, right? For space, at most, big O of 365 operations, because there could be 365 days that we have to account for. So it's just constant with respect to that, right? Because n will never scale larger than that. So in terms of n, well, it's not really in terms of n, right? Because if n was the length of this array, even if it was length 3, it might end up having to create a system that's much larger. But this is just much easier to process this way. That's why we do it like this. And since there's only 365 days, it's not an issue. All right, guys.